Hi, and welcome to Algebra 2. This is a lesson tonight on really a homework help for problems dealing with rational functions. So we're just going to deal with the rational expressions, the functions, talk about the domain, values that are not in the domain, how do you know what values make the rational function undefined, and things like that. Okay, so let's get started. So the first problem is, which of the following values of x is not in the domain of the following function? And the function is f of x equals x plus 3 divided by x minus 7. Okay, now we're talking about values not in the domain. We want to know where this is undefined. And it's undefined at values that make that denominator equal to 0. So x minus 7 equals 0, x equals 7, and the answer would be 7. That's the value that is not in the domain of the function. Okay, second problem. Which of the following values of x is not in the domain of this next function? So g of x equals, and we got 4x minus 1 divided by 2x plus 1. Again, we have the same concept, not in the domain of the function. Where is it undefined? Our focus is denominator. What value makes this 0? Therefore, to solve that, you just set it equal to 0. Minus the 1 from both sides, divide by 2, and the answer is x equals negative 1/2. Okay, on to the next one. The next one is a different binomial, but which value of x, when substituted into the function, would make it undefined? Now, in this case, we have a function that has to be factored first in the denominator. So this next one, you've got x minus 4 in the numerator, and now we've got a 2x squared plus 8x in the denominator. All right, so I want to know all the values that make it undefined. So I need to first factor the denominator by taking the, we'll take this and we'll just say, I could rewrite this as x minus 4, and then I can factor out a 2x and leave x plus 4. Okay, so 2x squared, 8x. And now this part and this part, each separately, have to be set to 0, because think about it, by the zero product property, if one of these two factors equals 0, then the whole denominator would equal 0. So in this case, we want to take both the 2x, set it equal to 0, and also the x plus 4 and set it equal to 0. These are the values. X equals 0 when we divide by 2. And x equals negative 4. So the values that are not in the domain of the function, or the values that would make it undefined, are x equals 0 and negative 4. Okay, and the values that make it 0. Okay, in the next case, we want to find the domain of the function, and the denominator has a trinomial. So we're going to set the trinomial in the bottom equal to 0. So we've got an x squared minus 4 in the numerator, and we've got an x squared plus 5x minus 14 in the denominator. Okay. Again, we could factor this on the bottom, and when you factor the bottom, you're going to break up into sets of parentheses. So y equals x squared minus 4, two sets of parentheses. Think numbers that times to give you negative 14 and add to give you positive 5. So negative and a positive are necessary to get the negative product. We need a 7 times a 2 to give you the 14. We need a positive 5, so we need x plus 7 and x minus 2. Okay? So again, each of these factors have to be set equal to 0. And x plus 7 equals 0. So x cannot equal negative 7, and x minus 2 equals 0, and x cannot equal positive 2. So the domain of the function are all the x such that x does not equal negative 7, comma, x does not equal positive 2. Okay, and that's how to state the domain. You have to state both. Okay. All right. Looking again, we have another one about the domain of the function, which has another trinomial in the denominator. Okay, so I'm going to erase this. We've got a 3x minus 1 in the numerator, and a 2x squared minus x minus 10 in the denominator. And I'll just put y equals. Okay, so I'm going to take that denominator and set it equal to 0, factor, and solve for what values make it 0. Okay, so now we have 2x and x. I need factors of 10 that are negative, and I need a negative 1 here, so I need to figure out what values they are. So let me try a 2 and a 5 here. That'll give me 5x, that'll give me 4x, and subtracted will definitely give me 1x, but I need the negative to be with the 5 and the positive to be with the 4 in order to get the negative 1. So I'm going to put the plus here, the minus here. Then you take each of the factors and set them equal to 0. So 2x minus 5 is 0. X equals 5/2. And x plus 2 equals 0. X equals negative 2. Okay, so the domain of the function are all the x such that x does not equal 5/2 and x does not equal negative 2. Okay, moving right along. The next one is a composite with a value g at f at negative 5. So this is a little bit of a spiraled concept of doing composite functions. We're plugging in negative 5 to the f function. The f function, f at x, I'm going to put f at negative 5, is 2 times negative 5 plus 7, since it was 2x plus 7. Find that value and then plug it into g. So that's negative 10 plus 7, which is negative 3. And now we're going to find g at negative 3. And the g function says it's a rational function where the negative 3 is squared minus the 4 divided by 2 times negative 3 plus 1. Okay, so that's 9 minus 4, which is 5 in the numerator, and negative 6 plus 1, which is negative 5. And so that value equals negative 1 in the end. Okay, so g at f at negative 5 equals negative 1. Okay. I'm going to go to a y-intercept of a rational function now. So if I'm looking for a y-intercept, the y-intercept is the place where the graph crosses the y-axis. And as you know, this is where x equals 0. So a y-intercept is the same thing as saying is where x equals 0. So basically you set x equal to 0 and solve. So we have a rational function here, y equals 2x plus 15 divided by x minus 3. Okay, and I want to know when y equals 0. Well, if y equals 0, what's that? It's the same as saying what value of, x equals 0. Oops, sorry. X equals 0, I'm going to plug in 0 here, and the 0 here, and solve the function. I was thinking x-intercept for a second. This times 2 is 0, plus 15 is 15, and that's negative 3, so the y would equal negative 5. So 0, negative 5 is the y-intercept of the function, okay, or negative 5. Okay, if I was to ask you for the x-intercept of the function, that's where y equals 0. And where y equals 0 is basically saying where does the numerator equal 0? Because if I was to take x minus 3 and multiply on two sides of the equation, the x minus 3's would cancel. And if those would cancel, then you'd be left with 0 times x minus 3, which is 0, equals 2x plus 15. Subtract 15 from both sides. Divide by 2. So negative 15 halves equals x. So the x-intercept is negative 15 halves, comma 0. The y-intercept of that function is 0, negative 5. Okay. Let's just practice a little bit of doing an inverse of a rational function. Again, an older concept, but we're doing it now with rational functions, so it's a little bit more complicated. Okay, first function is y equals 5x over x minus 2. Now, as you recall, inverse of functions is switch x and y and solve for y. So the inverse of a function is a reflection in the y equal x line. The y equal x line would swap the coordinates, so the x would become the y and the y would become the x. So you do that when you're trying to do it algebraically with the function. So I'm going to let x equals 5y over y minus 2, and now I have to solve. So first step is multiply both sides of the equation by y minus 2 to eliminate the y minus 2 denominator. So the y minus 2 here and here. Then distribute the x into the y minus 2. Move the y terms to the same side of the equation. Move the x term to the other side of the equation. Factor out the y. And divide both sides by x minus 5. There you go. There is the inverse function. Y inverse is 2x over x minus 5. Okay? The domain restriction here would be x cannot equal 5. And just doing another practice, we've got 3x plus 2 in the numerator, denominator of x plus 4. Again, we want to find the inverse function. So we're going to do the swap, the xy swap. So x equals 3y plus 2, y plus 4, same steps. Multiply both sides of the equation by y plus 4. So x times y plus 4 equals 3y plus 2. Distribute xy plus 4x is 3y plus 2. Like terms to same sides, so we're going to do the minus the 4x that way and the minus the 3y this way. So xy minus 3y equals negative 4x plus 2. I guess I could have written 2 minus 4x. Distribute out the y. Divide y into both terms, leaving with x minus 3. And the last step now is just to divide both sides by x minus 3. Y inverse equals negative 4x plus 2 divided by x minus 3. With a domain restriction, x cannot equal 3. Okay. All right, that's it for tonight. And a little bit of rational functions, finding the inverse, using composites, and finding domains and domain restrictions. Hope you enjoy the video, and see you in class. Bye.